Have you ever looked at a mathematical equation, something as simple as y equals 1 over x, and wondered how it turns into a beautiful, elegant curve? Well, today, we're going to go on that exact journey. We're going to connect the dots, literally, and build this graph from the ground up to see the hidden beauty in the math.
So this right here, this is our destination. It's a graph called a hyperbola. And what's really cool is how these two curves get closer and closer to the axes, like infinitely close, but they never actually touch them. So the big question is, how does all of that complex behavior come from something as simple as y equals 1 over x? Let's break it down.
Okay, so before we can even start plotting points, we have to pick the right tool for the job. And that means we really need to get the difference between an equation and a function. They look super similar, I know, but one of them is way better for actually building our graph.
Think of it like this. An equation, like xy equals 1, it just shows you a relationship. If you want to find y, you got to do some work first. You have to rearrange things. But a function, like y equals 1 over x, that's more like a direct command. It's a little machine. You pop in an x, and boom, it spits out a y right away. And for building a graph one point at a time, that direct input-output machine is exactly what we need.
All right, now that we have our function, the investigation can begin. We're going to be like detectives at a crime scene. We'll start by gathering the most obvious clues, just a handful of simple points to see what kind of pattern starts to show up.
So the first step is pretty simple, right? We're just going to plug in some basic whole numbers for x and see what y values our function gives us. If x is 2, y is 1/2. If x is -4, y is -1/4. But, and this is important, look right in the middle of that table. This is maybe the biggest clue of all. When x equals 0, the function is undefined. You just can't divide by 0. And that one little fact tells us something huge about the shape of our graph.
So when we plot those first few points, this is what we get. Yep, just a few lonely, disconnected dots. It's not exactly the elegant curve we were promised, is it? So what are we missing here?
Yeah, this can't possibly be the whole picture. The real story, the interesting part, it has to be hiding in all that empty space between the points we've plotted. So what's going on there?
To solve this mystery, we're going to need more evidence. It's time to start filling in those gaps and, thicken the plot a little by adding a bunch more data points to our graph.
And the way we do this is by using rational numbers. All the fractions and decimals that live between the whole numbers. By plugging in values for x like 1.5, or 2 1/4, or 1/3, we can generate a ton of new points to start filling up our map.
And as we do that, just look what happens. The more points we add, the more the hidden shape starts to emerge from the fog. You can clearly see the outline of two distinct curves taking form. It's not just a random collection of dots anymore. We're looking at the skeleton of our final graph.
So we've gone from a few dots to a pretty clear skeleton. But how do we make that final jump to a perfect, smooth curve? What's the last secret ingredient we need to complete the picture?
The answer is the set of all real numbers. This includes everything we've plotted so far, the integers and the fractions, but it also includes all the irrational numbers, things like pi or the square root of 2. These are the numbers that fill in every single tiny infinitesimal gap left on the number line. They make sure there are absolutely no holes.
And here it is. This is the final result. When we use every single real number for x, except for 0, of course, all of those infinite points just merge together. They form those two beautiful, smooth, continuous curves of the hyperbola that we saw right at the beginning. This is it. This is the complete visual story of y equals 1 over x.
So, we did it. We successfully built our graph. But what's the big takeaway from all this? Why did we go through all these steps in the first place?
Well, this whole process, it shows us the incredible power of a graph. It's really a tool for translation. We start with something abstract, just a relationship written in symbols, and by carefully finding every single point that makes it true, we translate it into a visual story. And that picture lets us understand how the original relationship behaves, all in a single intuitive glance.
And that's really the core idea here. A graph isn't just a pretty picture, it's this incredibly powerful tool for understanding. Things that can feel abstract, like rates of change or limits, they become actual shapes that we can see and we can analyze. We can see where a function is going up, where it's going down, and where it breaks, all just by looking at it.
And that leaves us with one final thought. We've just uncovered the visual story of y equals 1 over x, but there are countless other equations out there. So the real question is, what other amazing shapes and fascinating stories are just waiting to be discovered inside of them?